Hi guys, welcome to our YouTube channel. My name is Mr. Zest from Zest Academy. Alright, so what are we doing today? Today we are doing simultaneous equations. Right, if you are new, don't forget to like, share and subscribe. Please share with your friends so that they can also benefit. They can also benefit from this. Great. So what are the steps to follow when you're doing simultaneous equations? Step number one, you need to isolate one variable in one of the equations. So usually we use two variables. It could be x or y or any other variable, or it could be any other variable that you can use, right? And then what are you going to do after that? You need to substitute the expression obtained into this variable whenever it appears in the other equation. And then what is the most important thing that you need to always check? Always look for the variable that is the easiest to isolate in the simplest equation. So you don't want to choose an expression, or you don't want to choose the equation that is actually difficult for you to solve. So you must always look for the one that is the easiest to solve, and also look for the variable that is easy to isolate. Great. So let's do some examples. Let's apply all these rules or all these steps in one of our examples. Right. I'm going to do example 1. Right, so I'm going to use the substitution method. Right, let's say you are given solve for x and y. So given 2x plus y is equal to 1, and xy minus x squared plus y squared is equal to 5. Right, if you look at these two equations, you see that it is easy to make y the subject of the formula in the first equation. You see that equation 2, it's not easy to make y the subject of the formula or x the subject of the formula in equation 2, because the highest degree of x is 2, the highest degree of y is also 2. So it is easy to make the first equation, to make y the subject of the formula in equation 1. So I'm going to name this equation 1, and I'm going to name this equation 2. Then what am I going to do now? Now, like I said that it is easy to make y the subject of the formula in equation 1, so I'm going to make y the subject of the formula in equation 1 because it is easy. It is the variable that is actually easy to make the subject of the formula, or to isolate. Right, so let me isolate that. So if I isolate y, I'm going to have y, then I'm going to take 2x to the other side, then I'm going to obtain 1 minus 2x. And then I'm going to name this equation number 3. So what is the next step? I'm going to substitute. I'm going to substitute equation 3 into 2. You can't go and substitute equation 3 into equation 1 because you used equation number 1 to make 3. So you must always substitute equation 3 into the other equation. Right, so let's do that. Wherever we see y in this expression, wherever we see y, we're going to substitute that with 1 minus 2x. So let's do that in this equation. Right, so here we have x, then we see y, then 1 minus 2x, and then minus x squared, and then here we have y, so we're going to have y minus 2x, all squared is equal to 5. Then we solve for this. Right, so remember, actually we simplify. Like, let's distribute this x times y, x times negative 2x. So it's going to have, we're going to obtain negative 2x squared. And then negative x squared plus, right, now here we have this expression 1 minus 2x squared. This is actually the same as if you have a minus b all squared. What is it that you're going to obtain? You square the first variable or term, and then you multiply these two variables twice. A times negative b, negative ab, a times negative b, negative ab, negative ab, negative ab, you obtain negative 2ab, and then you square the last one, negative b squared, we're going to obtain positive b squared. So we are going to apply this here. This is what we're going to apply. You can also expand these two, negative 2x, 1 minus negative 2x. You can also do this. You can also expand this. But then if you know how to do this, then it is actually easier to do so. All right, so let's apply this. So what are we going to have here? If we square 1, we're going to obtain 1. And then if we do this, 1 times negative 2x, so that's negative 2x, 1 times negative 2x, negative 2x, negative 2x, negative 2x, we're going to obtain negative 4x. And then we're going to square the last one, negative 2x squared, we're going to obtain positive 4x squared is equal to 5. Now, this is just simple algebra where we collect like terms. Let's collect like terms. Right. If we collect like terms, we're going to see that we have negative 2x squared and 4x squared. And then we have negative x squared. So what are we going to obtain? We're going to obtain x squared. And then we have x and negative 4x. See that we will obtain negative 3x. And then this side we have positive 1. If we bring this side, we're going to have negative 4, all equal to 0. Right. Why did I do this? You see that the highest degree is 2, so we knew that we were going to obtain a quadratic. So this is actually a quadratic, a trinomial. We know how to solve for x when we get this, or solve for any other variable if it's a quadratic. So what are we going to do? Open bracket, open bracket, open bracket is equal to, and equate that to 0. And then we're going to have the value of x and x here. And then what are we going to do? We're going to look for two factors of 4 that when we multiply them, they give us 4. But when we add them or subtract them, they give us 3. Those are 4 and 1. The sign of the constant is negative. So it implies that inside the brackets, our signs are going to be different. But how are they going to be different? The bigger factor between the two factors is going to take the sign of the middle term. Right, so the bigger factor is 4, so it is going to take the sign of the middle term, and that is negative. And obviously the other one is going to be positive. So therefore, x minus 4 is equal to 0, or x plus 1 is equal to 0. Right, solving for x, then we're going to obtain x is equal to positive 4, or x is equal to negative 1. Right, these are values of x. We still have to get the values of y, because here we are solving for x and y. So we still have to get the values of y. Right, so what are the values of y? What are we going to do now that we obtained this? Remember, we made y the subject to formula when we started. So you're going to substitute these values into equation 3, to obtain the values of y. Right, so y is equal to 1 minus 2. So for this one, the value of x is 4. When the value of x, we obtain 1 times negative 8. And then that's going to give us negative 7. And then y is equal to 1 minus 2 times negative 1. Right? Negative 1 times negative 2 times negative 1, that's positive 2. Positive 2 plus 1, we're going to obtain negative 1. Right, so these are the values of x and these are the values of y. So finally we have solved our simultaneous equation. Right, so you can also test if this is true if you want. So you can choose any two values. So you can choose the value of x. When x is equal to 4, what would be the value of y? The value of y is negative 7. And then you can substitute them into any of these two equations and see if the left hand side will be equal to the right hand side. Right, so we can test that here. Let's take equation number 1 and see if this is going to work. Right, so the value of x is 4. So let's test. Right? 2. So the value of x is 4 times 4. What is the value of y? When x is equal to 4, the value of y is negative 7. So here we're going to have negative 7 and see what we obtain. So what are we going to obtain? Remember, this is the left hand side. We want to see if it's going to be equal to the right hand side. 2 times 4, that's 8 minus 1. That's going to give us 1. So therefore, the left hand side is equal to the right hand side. So this is actually, so it means that the values of x and y that we obtained are correct. Great. Don't forget to like, subscribe and share. Please share with your friends so that they can also benefit from this. We highly appreciate your support. Hi guys, welcome back. So I decided to do example 2, just to enhance your understanding, just to make sure that my students actually understand. Right, so here's another simultaneous equation. Here we're given x plus 3y is equal to 5, x squared minus 3x plus 10y is equal to 8y squared minus 18. Right, so if you look at these two equations, you see that it is easy to make x the subject to the formula in the first equation than it is to make x or y the subject to the formula in equation number 2. So with that being said, so we are going to make x the subject to the formula. We're going to isolate x in the first equation. So I'm just going to name this equation number 1, and I'm going to name this one equation number 2. Right, then from that, like I said, that it is easy to make x the subject to the formula in equation number 1. So I'm going to isolate x in equation number 1, then I'm going to obtain x is equal to, then I'm going to take everything to the other side, so I'm going to obtain 5 minus 3y. And this is going to be my equation number, this is going to be my equation number 3. Then, what am I going to do with equation number 3? I'm going to substitute this expression wherever I see x in equation number 2. Right, so here I come across x, so what am I going to do? I'm going to substitute this expression. So what am I going to obtain? I'm going to have 5 minus 3y all squared, because it is squared, and then minus 3, here is another x, 5 minus 3y plus 10y is equal to 8y squared minus 8y squared minus 18. Right. Remember, if you have a minus b all squared, what you obtain a squared, you square the first term is the first variable, and you multiply this twice. A times negative b, negative ab, a times negative b, negative b, negative ab, negative ab, negative ab, you obtain negative 2ab. Then you square the last one, negative b squared, you're going to obtain b squared. So we are going to apply this here. Right, so what are we going to have here? Square the first one, we're going to obtain 25. 5 times negative 3y, negative 15y. 5 times negative 3y, negative 15y. Negative 15y, negative 15y, we're going to obtain negative 30y. Then we square the last one, negative 3y all squared, we're going to obtain positive 9y squared. And then what are we going to do? We're going to distribute this in here. Negative 3 times 5, that's negative 15. Negative 3 times negative 3y, positive 9y, and plus 10y is equal to 8y squared minus 18. Right. So what are we going to do now? Now, because I see the highest degree here is 2, the highest degree is 2. So what are we going to do? We know that we're going to obtain a quadratic, so we can take everything to one side of the equation and equate that to to 0. Right. So what are we going to obtain here? If we do this, we see that we're going to obtain this side we have positive 9y squared. If we bring this one, this side is going to be negative 8y. So we're going to obtain positive y squared. And then here you can see that we have negative 30y, and we also have positive 9y, and then we also have 10y. So from that you can see that we're going to obtain negative 11y. And then our constants, if we here we have what? We have 25 minus 15, that's 10. And if we bring this one this side, we're going to obtain positive 28. And that is equal to, we equate that to 0. Right. So you can see that here we have obtained a quadratic. So what are we going to do with this quadratic? We're going to factorize that as we always do to solve for y. So open bracket, open bracket, open bracket, open bracket equal to 0. And then y. Then we're going to look for two factors of 28, that when we multiply them, they give us 28. When we add them or subtract them, they give us 11. Those are 7 and 4. Then what about the signs? We know that if the sign of the constant is positive, we are going to have same signs inside our bracket. But how are they going to be the same? They will be the same as the middle one. So they're going to be negative, negative. Then, therefore, y minus 7 is equal to 0, or y minus 4 is equal to 0. Solving for y, take this one to the other side. So we're going to obtain y is equal to positive 7, or y is equal to positive 4. Right, now we have obtained the values of y. We now need the values of x. So what are we going to do again, like we did in our previous example? We're going to substitute the values of y into equation 3 to obtain the values of x. Right, so let's do that. What is the value of y? What is the value of x when y is equal to 7? So x is equal to 5 minus 3 times 7. You see that if we do that, this is negative 3 times 7 is equal to negative 21, plus 5, we're going to obtain negative 16. And then this side, x is equal to 5 minus 3, the value of y, 4, what will be the value of x when y is equal to 4? You'll see that you're going to obtain negative 7. Right. Now we have all our values, the values that we were looking for. We have the value of x, we have the value of y, we have the value of x, and we also have, so when y is equal to 7, the value of x is negative 16. When y is equal to 4, the value of x is equal to negative 7. Right, like I said, you can also test if you want to see if this is true. You can also test, you can just choose any two and test if that is true. Right, test. So we can just take these two or these two and see if we are going to, the left hand side of our equation is going to be equal to our right hand side. Right, the value of x is negative 16 plus 3 times the value of y, that's 7, and see what we obtain. So here we're going to get negative 16 plus 21. So you can see from this that you're going to get 5, and that's what you have. So if we substitute these values, the value of y and the value of x, into equation number 1, you will see that the left hand side will be equal to right hand side. So it means that the values that we obtained are correct. Great. So for more, don't forget to like, subscribe, and share. Don't forget to do what? Subscribe, like, and share, so that your friends can also benefit from this. Right. Lastly, I would like to wish all the current grade 12s the best of luck as they are about to write their prelims. Just focus and study hard. You're going to make it. All the best. Ciao.